Hi and welcome back to my awesome math videos. Today we are going to talk about, it will be the last video in this series on functions. So previously we talked about what is a function, we talked about vertical line test, horizontal line test, and then we talked about the domain and range, which is like the bane of many math students' existence because people tend to forget what these things mean. So please check out those videos. Today, we're going to talk about operations on functions and composite functions. So two different things. They are related, but in essence, they're different to each other. The math part will not be so hard because it involves operations that you have done before to death, like addition and subtraction and multiplication and division. No news, but the language is new. So we need to be able to write things mathematically, and we need to be able to understand the exam style question so that we are able to answer it, because otherwise we're lost, not because we don't know math, but because we don't speak math. Okay, so let's do some examples and we're going to take it from there. Let's say I have two different functions. Let's say I have f of x equal to 3x minus 1, for example. And let's say I have another one, g of x equal to, I don't know, it can be, so x squared plus 2, for example. So my rule for f is that I have my input number, the x, I'm going to multiply it by 3 and then minus 1. So my f of x is equal to 3x minus 1. For g, I'm going to square my number and then I'm going to add 2. So operations on functions. Let's do this one first. What does this mean? For example, let's assume that you're asked to evaluate the following. F of 1 plus g of 2, for example. Okay, so what is this equal to? I'm telling you, this is a number, it's equal to a number, but how do I calculate this number? What does this even mean? So let's do it step by step, carefully. So the number 1 is the input to the function f. It means that the x for my f is something that I should multiply by 3 and then take minus 1. So, okay, if I follow the rule for f, I should have 3 times 1, so 3 times 1 minus 1. Okay, and then I want to add g of 2, but for g, I have a different treatment of my variable x. So now x is equal to 2, but for g, so 2 squared plus 2 I should have, because that's what my g is telling me. So 2 squared plus 2. And after that, we're back to regular math, where we'll evaluate what this is. 3 times 1 minus 1, well, 3 times 1 is just 3, so I have 3 minus 1 plus 4 plus 2. Like this. And this is equal to, so 3 minus 1 is 2, 2 plus 4 is 6, 6 plus 2 is 8. So my answer is f of 1 plus g of 2 is equal to 8. This is a very good example where the language is new, but the actual math, this addition, you have done, I don't know, in elementary school. So please make a habit of trying to understand what this language is about, so that you will be able to answer the question. Let's do another example whilst we're here. Let's do f of 2 minus g of, for example, what can we take? G of negative 1. And let's see what the answer is. So how is this any different from the other one? Well, in theory, it's actually not different. My x is equal to 2 when I'm evaluating my function that I call f. So I will have 3 times 2 minus 1 here. And then I will take minus, and I must use brackets here now because I have a negative of all the g, of everything that appears in the g of negative 1, I will minus it from what I had before. So I have several terms in my g function, so I will have a bracket because minus will be everything that will appear inside here. g of -1, what is that? So I have x is -1 for my g, so I will have -1 squared. -1 squared plus 2, like this. And now I can close my bracket. And now I'm down to basic math again. So 3 times 2 is 6. 6 minus 1 is 5. And then I have minus what? Let's keep the bracket for now. -1 squared is +1, right? So this is 1. 1 plus 2 is 3, so -3. I can just write this as 5 minus 3. When I only have a number left here, I can take away the bracket. 5 minus 3 is equal to 2. So this is my answer for that question. So good. Now we have seen how we have done 2 examples of operations on functions. And please make a habit to use the worksheets to try to solve many questions like this. And after a while, it will go quick and easy. We will do one more example before we go into composite functions. Let's evaluate f of 2 multiplied by g of 3. Okay, what is this equal to? Now, with multiplication, the same consideration as I had with subtraction is that this number, that it is the result of my calculation from f, is to be multiplied by the result of my calculation with g. So there are several steps inside this f that I need to do to get this result, and the same thing for g. This means that all these things that I will have to do will appear inside some brackets for f. And then it's multiplied by all these brackets, all these calculations that appear in g, and those will take place inside this bracket. Okay, so what do I have? F was the blue one. Let's see here. So f of x is 3x minus 1, and x was equal to 2. So I will have 3 times 2 minus 1. That's this guy. Let's see what happens with g. G of 3. Well, for g, I have x squared plus 2. So when x is equal to 3, I will have 3 squared plus 2. So 3 squared plus 2. And good. Now we're down to the math part again, the basic math part, let's say, operations on numbers. 3 times 2 is 6. 6 minus 1 is 5. So I will have 5 there. Multiplied by 3 squared is 9. 9 plus 2 is 11. So 5 times 11. This is equal to 55. So this is my answer here, operations of a function in this case. Good. So if my input, on the other hand, involves symbols, let's say I was asked to evaluate f of x times g of x, then my answer will also have symbols. I will answer in terms of x, or a, or r, or any other letter that we might choose. If your question involves only numbers, then your answer will be a number as well, because there are no unknowns in the problem. Okay. Let's do the next one. Let's do the composite functions. Okay. Composite functions, what does that mean? Composite functions means that you have a function inside a function. We might be asking you, what is f of, and not a number now, we will have g of 1, for example. There could be any number here, I will take 1. So before you fall off your chair in amazement what this means, let me just very quickly explain what I'm trying to do here. This means that g of 1, I'm following the rule for my g, it is here. I will evaluate, I will get some number. That number is the input into my function f. So this is like having a function inside a function. What does this equal to? Let's do this example. So I have g of 1 is equal to, g of x was x squared plus 2. So it's 1 squared plus 2. 1 squared plus 2. This is equal to 3. So this 3 goes into my f, because my f was supposed to have g of 1 as input. this is my input for f, and this number, g of 1, is equal to this. So this means that I need to evaluate here f of 3. This 3 is my result of g of 1. So I have this thing left to evaluate, and f was 3x minus 1. So I will have 3 times 3 minus 1, which is nothing else but 9 minus 1 is equal to 8. So in other words, in composite functions, you are having, instead of f of x or g of x, you are having f of g of x, like this. So the input is a function. If you're having this machine model where x goes into the black box that we call f, this is the name of my function, and out comes an f of x, then in this case with composite functions I have an x going into the function g, and g produces a number that's g of x, and this number goes into the function that I call f. So out pops nothing else but f of g of x, like this. If you are studying the worksheets, you might come across something that looks like this. F ball, this is like a circle, a ball. You can say O, so let's call this is fog. Fog of x. Or if we turn it around, it will be g ball f. This is gof of x. This notation, this is a different way to speak math. This means the same thing as this. So this means f of g of x. And this means, now I have turned it around, I try to be smart here, it's g of f of x. So what I'm doing in math, it doesn't change, but they write this small ball in between the two symbols. It's a different way of writing the same thing.